All right, sequences. So I'll rush through this so that you guys can go, but when finding missing values in sequences, you got to determine what operation is being used and how it is being used. Now, if we go back to the multiplication table on this one, it would help us actually. Like you'd say, oh, you know what? I can find these values in the multiplication table, which means we're using multiplication, by the way. And you'd say, oh, there's 16. Well, I'm going to highlight that. Uh, There's 16. There's 25. I'm just going through the sequence, right? 36, 49, 64, which would tell me from the table that the next value has to be 81. Okay, so that's using the table, but there is another way. And you may like this way, you may not. It may be more convenient for you, so it may be more practical. But what I would do is I would look at these values and I'd say, using either addition and subtraction generally is a little bit more acceptable, a little bit more usable, I guess. So I'd say 16. What do I have to add to 16 to make 25? That's old niner. And yeah, I am kind of going through this a little fast, I know, but then I say, well, 25 to 36. What would I have to add to 25 to make 36? That's 11. What about 36 to 49? That's 13. 49 to 64? 15 right there. Now, I didn't actually do the math on the 15, and I didn't really have to because I saw a pattern with these changes, right? From each term to each term. It went from 9 to 11 to 13. Naturally, the next number should be 15, right? It's just 9, 11, 13, 15. That's just adding 2 each time to these changes, which means to go to the next value, I take 64 and add 17. So, okay, you got 64 and add 17. So there's 11. 1 plus 6 plus 1 is 81. There it is. That's the same number that we got right there. So that's 2 different ways to do it. Well, since we're talking about square roots, generally these have to do with either exponents, like some number times itself, or square roots kind of stuff. So expect that, but you can solve it using changes by addition like this as well.